il prossimo talk è sempre offerto da SIGAP e lo speaker è Angel, che sarà collegato dalla Spagna, da Madrid, per cui adesso passiamo all'inglese per introdurlo. Angel, good morning. Good morning from Madrid, right? How are you?
Good morning, Rocco. Yeah, I'm fine. I'm very glad to be here. Yeah, as you said, I'm in Madrid, so sorry for the switch of the language. So yeah, thank you for.
Absolutely, no problem. So I was reading your bio, and you basically started your career as a full stack developer. At some point, you kind of looked into the dark side of the platform, and you wanted to see what's going on over there, right?
Yeah, exactly. You know, when you are a developer and you think about where to put your application on to show you to other college, or or make it public available, you start thinking about where to place it, and you discover the cloud. And this is what happened to me. I discovered that I can place my code in someone else's computer, and I can run it from there. So this is why I switched.
Absolutely. And your current job at SIGAP is mainly revolving around building and maintaining your Fury Kubernetes distribution. Is that right?
Yeah, exactly. Among other products of other open source projects. Yeah, that's my main objective there.
Okay. But today, actually, we're not talking about Fury and Kubernetes, but we are talking about supply chain. That's a topic that, especially lately, have been some sort of hot topic, especially because supply chain has been mentioned and evolved several times into security issues, if you want to call it that way. And so your talk today is have the title of Building a Secure Supply Chain. Just give us a little bit of introduction about what you're going to talk about, and I'm going to tell the audience that the talk is pre-recorded, actually, and we're going to stream it. But at the end, Angel is going to be with us live to answer your question.
Yeah. So the talk is about what you said. It's like building a secure supply chain. And what that means is, when you are building your software, you can build as usual, and you can output a running application without any problem. But it's far from being secure by default. So you have to trust, you have to design, and you have to build not only your application, but also the supply chain. Because if you cannot trust your supply chain, or your supply chain is compromised, the resulting application is going to be also compromised or vulnerable. And we are going to talk about CI/CD system. We are going to talk about Docker files and so on. So you can imagine what is the content, more or less.
Okay, amazing. Thank you. So we can start with the video. Just remember the audience to use the chat to post all your questions, and see you later, Angel. Thanks.
Thank you. Thank you, Rocco.
Hello, and welcome to this session. First of all, I want to say thank you to the organizers of the Incontro DevOps 2021. I think it's the second time in a row that I am participating here in Incontro DevOps. Unfortunately, this 2 times was in remote. Let's see if the next time I can be present there. Today, I am going to talk about how to build a secure supply chain. And this is kind of related with a product that we are building at CHAP, which is the CHAP certified container images. My name is Ángel Barrera Sánchez. I'm based in Madrid, Spain. And currently I'm working as a Kubernetes engineer at CHAP.io, as you can imagine. And what it does mean is that I'm responsible of the Kubernetes view distribution, which is the certified from the CNCF Kubernetes distribution from CHub. And also I work on other small and medium open source projects from chub.io. So yeah, that's the introduction. Let's start. So first of all, let's review the agenda. We're going to cover what is a supply chain, and for sure more focus on the software ones. We are going to see how is a traditional software supply chain, and something that we used to see very often in the enterprises, which is the how the organization are creating their own set of base images, hardened for sure. And we are going to expose what is our approach to tackle this problem. And last but not the least, I'm not sure if we are going to have enough time to see the demo in action, but for sure I will give you a link to test the demo by yourself after the meeting. So yeah, let's start with the supply chain and more focus on how is a software supply chain. I like to compare the software industry with the restaurant industry, because both has some similarities. Like, okay, someone in the restaurant creates a recipe, then the cooking line or the kitcheners creates food from the recipe, following a recipe from a chef, and then the waitress delivers the plate of food to the customer or the client in the restaurant. Something similar applies to the software industry. Someone designs a recipe or a software, and then the developers creates the actual software, and then someone else delivers the software using traditional delivery methods like container registry or something like that, and then the clients pull the container from the registry and use it for free. So yeah, let's see how is the supply chain in a restaurant. As I mentioned before, a chef creates a recipe based on his or her experience in the kitchen. So maybe the chef tests with a few ingredients and few temperatures and few procedures to create the food. And once the chef is comfortable with the result, he creates the recipe and he places the recipe into a recipe book, where the kitchener can see and show how the food has to be created. So the kitchener can reproduce the recipe to create multiple identical plates of food. And this is really important. I mean, you have to know, you have to know and you have to read carefully the steps to reproduce the food, because otherwise it will end up with multiple outputs, and we don't want it. We want to have a recipe that it's easy to reproduce and to create reproducible plates of food. Then once the food is ready, it will wait in the bar room or something like that to some waiter to serve it to the actual client, to the end client or end customer. So as you can see, there are like few steps, like a supply chain, where there are steps like creating the recipe, then bake the food, and then the restaurant bar, the food is in the restaurant bar, and then the food has to deliver to the client. And more or less the same applies in the software industry. An engineer or an architect with enough experience creates a container image definition based on his experience, based on the security restriction that the company applies to this kind of software. Then the CI/CD system gets the the container image definition, which is available in a version control system like Git or Subversion or Mercurial or any other. So the CI/CD system grabs the definition and creates a container image from the definition. And finally, it pushes the resulting container image to a registry. This can be made by CI/CD system like Travis, like Jenkins, like GitLab. In the end, is everything the same. And the container image is pushed to a container registry based on Docker registry or Harbor or Quay or any other alternative that you may consider. And finally, the resulting image is ready to be used by the clients. The client can create a container or can build their container images on top of this container image. Okay, that's perfect. Both have some similarities, so we can manage both as one, let's say. So what happens if the ingredients has been compromised? Even if it looks tasty, it can poison you. I mean, if you don't verify that your ingredients, if your dependencies are perfectly sane or whatever, you can get poison. Okay, you can get a food poison, and you don't want that. So even if the resulting image works, even if the food plate looks tasty, it can poison you. So the same happens, as I mentioned, in the software industry. Even if your recipe is perfect, even if the resulting image works, if you have a compromised dependency, you can get poison of your container image. Okay. So you have to check your dependencies or your ingredients before building your food or before building your container image. And what happens if you cook something, if you build a container image and you leave it for weeks or for months or for years in your container registry or in your restaurant bar? Even if it runs, even if it looks tasty, it can poison you. Okay. And why it is happening? Why it can get poisoned? Why it can get compromised? Because the ingredients has its own life cycle, as it has the dependencies, and the developers push some changes to patch vulnerabilities and also causes another vulnerabilities. And hackers are there. And even if you consider your food that it's perfect and it is perfectly sane and its tasty is perfect, if you leave it for weeks, maybe that's not maybe when you are to eat it, it's not going to be perfect for sure. Same happens with the software industry. If you build an image today, it could be considered secure, but for sure, if you leave it immutable for weeks or for months or for years, it is going to have some vulnerabilities on it for sure. So you have to periodically check the sanity of your food and of your container images. And why do we care about this kind of software supply chain security? If you know us, we are CHAT.io. We are listed in the CNCF landscape as a Kubernetes provider. So our main business is providing you a Kubernetes platform to develop and to run your applications. So we know perfectly that your business is about creating products, about creating software that makes money, basically. So your main business is to create new features, to create products as fast as possible. But at the same time, you have to rely on your supply chain. You have to be sure that your developers and all your supply chain behaves correctly to release high quality products. So even if you develop we perfectly know that developers has a lot of things in mind, like creating unit tests, like creating integration tests, end-to-end tests, smoke tests, stress tests. There are a lot of tests to do in your code base. But once you have to wrap your application and you have to deliver your application, there are more things to do. And this is something that we discussed before. You have to wrap your application in a container, for example, and then deliver it to your customers. So you may yes, may not be afraid of this, and this is why we care a lot about this supply chain. And we care a lot about it because we usually see this kind of definition, container image definition. As I mentioned, maybe the developer or maybe the development team creates a lot of unit tests, create a lot of integration tests, and so on. But maybe they don't run integration test against the container image definition, just the application.jar file. Okay, so this is usually what we used to see in the ecosystem, in the enterprise ecosystem. It doesn't matter if it is a small, a medium, or large enterprise. We used to see this kind of definition very often. And can you consider this container image definition secure? Maybe yes, maybe not. Who knows? First of all, you have to notice that you are using a Docker Hub upstream image, which is OpenGDK.17. But maybe you don't know what operating system is using OpenGDK under the hood. Maybe it's using Debian, maybe it's using Alpine, maybe it's using Ubuntu or CentOS. And you don't know the version. You don't know if it is Debian Buster, if it's Alpine 3.11, if it is Ubuntu 18 or Ubuntu 20. So you don't know nothing about your base image, let's say. And an interesting point here is that how often does the OpenGDK community patch the operating system vulnerability? Because the main business of OpenGDK is to maintain the JVM and the integration between the JVM and the applications, and to release JVM patches, features, and so on. But maybe it's not the responsibility of the OpenGDK community to patch operating system libraries if a vulnerability happens. So you don't know how often the OpenGDK community is going to patch the operating system vulnerabilities if they do it. Okay, the same happens with the OpenGDK version. Okay, if you look for the definition, you can see that you are using the 17 version of the OpenGDK, but you don't know exactly what version is using it under the hood. You don't know if it is 18.1, 18.3, 18.11. You don't know it. And this causes a lot of problems while debugging or while trying to replicate the same environment from production to development and to local. Because maybe in your local environment you have the latest 17 version and you cannot see the bug that is happening in production, which is using OpenGDK 17.1, for example. So yeah, it's super important to know exactly what version are you using. And again, it is kind of a bad practice somehow, or maybe not, but yeah, you can use the 17 version because it is supposed to be override by the OpenGDK community. I mean, if the OpenGDK community plays the 17 version to be 70.1 and then OpenGDK release 70.2, the OpenGDK community has to override the OpenGDK 17 tag to point to the 70.2 version. But you don't know when that happens. Okay, you have to set up some alerts and triggers and so on to be notified. And about Docker Hub and about pulling official or certified or unofficial images from Docker Hub, you have to take this into account. We see that the number of vulnerabilities on Docker Hub is increasing super rapidly. And the most impacted ones are the certified. The official is less impacted, but yeah, in the end, there are no correlation between the number of vulnerabilities and the number of pulls or number of images. The owner, it doesn't matter. You have to analyze your container images, even if it's something from Docker Hub or Quail or any other registry. Public registry mostly. Then we have an article from some days ago that they show that there are a lot of hijacked container image definition with Monero mining malware, and they are earning a lot of money using your own infrastructure, using your infrastructure in your company. What Monero does is using the CPU to mine the Monero coin, let's say, and yeah, it is causing plenty of bugs in your infrastructure because it uses your CPU and you cannot use your entire CPU to run your application because Monero is mining Monero coins. So yeah, there you have to be careful about vulnerabilities, but not also about vulnerabilities, but also about miners these days. So if we go back to the example that we were analyzing before, if you are an enterprise and you want to know the metrics about your application, you have to consider placing a Prometheus portal in your application, implementing some Prometheus client libraries like the Java ones to expose application metrics like, I don't know, if your application is related with transfers, with wire transfer or something like that, you may want to know how many wire transfer happens, what are the common origins, what are the common destinations, and so on. So this kind of metrics, you can implement this kind of metrics in your own application, implementing some libraries and interfaces. But what about the GVM? How do you keep track of the GVM parameters? How do you know how many times the garbage collector is passing each hour? How do you know how is the memory behaving? Because it's kind of important in GVM to track this kind of metrics. And also it's important to know how do you install share libraries against multiple container images, multiple microservices, for example. Imagine that you have to install a MySQL driver or an Oracle driver in your base image. How do you do that? Do you create a base image and then use this base image across all your applications, or you install on all the application the Oracle driver, for example? So okay, even if you build your image, let's say that you build your image, how do you ensure that your image is secure? How do you keep track of how many vulnerabilities does your container image have today? And how do you get alerts from new vulnerabilities? I mean, as we mentioned before, you cannot build an image and consider it secure forever. So if a new vulnerability appears on a dependency that you have installed, how do you get notified? How do you know if it's a critical one that can affect to your environment and your applications? And how do you get notified? And how do you apply new patches on the operating system or in your base image? It's something that you have to keep track, and you have to ensure that know how to do that. As we mentioned, OpenGDK has its own supply chain implementation. They release new versions once they consider, or once they have a new feature implemented, or once they have a new patch implemented. But you don't have control, or you don't have easy control over there. Maybe they are open and you can contribute to them, but maybe not. Who knows? And maybe you cannot have visibility on it. Maybe you cannot see the pipelines that build the images, or maybe you can see but you cannot trigger new pipelines. So what it used to happen in this kind of scenario is that big enterprise, or at least enterprise that can invest in a dedicated team to maintain and to create base image, they do it. They invest time and resources to create this kind of base images. But as we mentioned before, it's not one-shot investment. It's something that you have to do it periodically. You have to analyze all the images. You have to build your own pipeline. You have to build your own workflow to patch your vulnerabilities. You have to trigger rebuilding of the images. It's not easy. I mean, it's something that you have to know, and this is why this talk exists, So this is like the supply chain of how to build base images. It's super similar at the one that we saw at the beginning of the talk, that creates application container images, not base images. So an engineer creates a container image definition based on the request from the security team or from the product owner. It doesn't matter. It has to follow some guidelines. Then the CI/CD system creates the container image, the actual container image from the receive from the Docker file, sorry. And then the image is pushed to a container registry like Hardened, like Docker registry, or public ones like Docker Hub or Quay. And then the clients can pull the image and build the image on top of this kind of images. So yeah, this is how it looks like. Okay, now you have your example.com, your OpenGDK version. It's hardened, it has some patches. Okay, that's perfect. But how did you did it? How did you patch the vulnerabilities? And how do you get notified if your base image changed? Because I'm almost sure that you are not going to start from scratch, because maybe it's a bad practice. In some scenario it is, in some it isn't. But yeah, so in some scenario, starting from scratch is a bad practice, because you cannot easily debug a container image started from scratch. And yeah, how to get notified if Debian Buster, if you're using Debian Buster as your base image, how do you get notified if Debian Buster got updated? Because if it got updated, maybe you want to rebuild your container images. No? It's similar if you change your container image, if your enterprise-based images, you have to trigger your applications to rebuild, okay? And again, even if you have your container image, how do you get notified if there is a new vulnerability on the application layer or in the base image? And did you expose a catalog for your internal team? And what information does the catalog show? It's just the name of the images, or the name and the tags, the history, or what kind of content does it provide? So I'm almost sure that most of you had this problem before, and this is why we care about building a product and building a secure supply chain, software supply chain. And this is why we end up developing the CHA certified container images product. It's just, something that your development team can trust, blind trust, honestly, to create quality applications and secure applications. The most important part here is the security. So your team can build application on top of our certified images, because they are hardened by default, and we have all the mechanisms in place to get notified and to start working if something happens. So what we are offering is kind of a registry as a service, where our images are listed, and you can pull them and you can build on top of them. So what we are offering is a trust image source instead of using a public one where anyone can push images. We are offering an extensive report that shows almost everything about the Docker container image. And we have a lot of automatic workflows to get notified, to get alerts, and so on. And the most important part, if you care about, if you are working in an enterprise, we are providing SLA, 3 tiers of SLA for critical, business, and low. I don't want to stay here a lot of time. You can ping sales at cia.io if you have any doubt, if you want to know more about what are the difference between the different SLAs. Just take in mind that the critical is the best and the low is the lower, and so on. And I think that the coming 2 slides are the most important of this talk. And this is why and how we build our supply chain, let's say. So first of all, in the top left corner, the team creates a definition, a container image definition, which commonly is named Docker files. Then the Docker file is analyzed against some linting's requirement. And for example, what we check is that we don't run as root the container image, that all the dependencies has a strict version explicitly set. Once the image is built, we pass some vulnerability analysis. We pass 2 different vulnerability analyses. One is Claire and the other one is 3B. One is from CoreOS, Red Hat, and the other one is from Aquasec. And what it provides us is 2 different reports, and we can merge it somehow and see if something makes sense. Because if 3B reports, I don't know, maybe 1,000 vulnerabilities, but Claire just report 2, maybe something is happening with Claire, or maybe something happening with our container image, so we can take actions on it. And then once the image is scanned for vulnerabilities, what we do is to pass some end-to-end tests that we design using real applications. So what it means is that even if the image got built, it could not work. And this is why we ensure that running an application on top of that, makes us think that the image is right built. So yeah, this is something that makes us different from other providers, that we test our container images. We test end-to-end test our container images. Finally, we sign the container image and push it to a container registry, where we also push the report that you can see, and you can understand what is the status of the container image, of the resulting container image. Then we set up a set of notifications, meaning that if the resulting image has more problems than the previous one, we get notified and we can plan how to solve this bad behavior. But as I mentioned before, this is just the first step. Okay, this is the building phase. This is fine. But what happens the day 2? What happens when you leave the container image there for weeks? And this is why we set up a set of automations to check every day how is the status of the image, passing again all the linting, all the vulnerability scan. We pass again the end-to-end test. We do almost everything. And also we check if our base images change along the time, meaning that if we are using Debian Buster as base image, we check if Debian Buster overwrites the tag. So we rebuild the image to get the latest version of Debian Buster. And again, we passed all the linting, all the vulnerability analysis, everything with the same automations. And once a week, what we do is to force rebuilding all the images. And this is because some layers has like a procedure to upgrade all the dependencies. So if you don't trigger that, you don't update all the dependencies, just the ones that you have in your container image definition. So it's pretty important to have at least these day two operations automated. Again, the most important part is how the team is notified and how we plan to fix all the errors. I want to show you a demo, but I don't think I have enough time. But you can see the demo from Katacoda. In Katacoda, we create a scenario where you can test the Java certified images from CHAP. We create a kind cluster with a Java application that you can build, you can develop, you can deploy it on the kind cluster, you can inspect from the signature and so on, and you can also test it. And the important thing here is that we also add the GNX export by default already configured, so you can keep track of how many garbage collector events are happening and how is it behaving. So I will leave the link in the comment box, so you can go and test the CCI by yourself. And now I'm open for the Q&A. Thank you so much. It is a pleasure to be here again. So yeah, let's go. Thank you.
We're back live. Welcome back, Angel. Thanks for the talk. So while we wait for the people from the chat to leave their questions, I have a couple from myself, if you don't mind. And basically, I'm curious to understand what were the challenges you have to face while building this product, because you described in details all the things you are doing, all the information you're getting, but then I guess there is a lot of, let's say, interpretation on top of all this information to take decision and understand, what is good, what is bad, and how to approach issues and stuff. So if you can elaborate on that a little bit.
Yeah, I think that the most challenging stuff that we did at CHAP was to automate almost everything. I mean, we have some automation that was not out of the box with the traditional security scanners like 3D Clear and so on. So what we did was super challenging, was to automate to get alerts on already existing container images and already existing Docker registry and so on. There are some Docker registries that already integrate this kind of security checks or sanity checks, like Harbor. Harbor has a lot of integration with some security scanners. But first, it lacks the alerting system, so you cannot get notified or easily get notified. And also, it doesn't trigger any kind of rebuilding of your CI/CD system or the supply chain. So, okay, you have something, but this small step, which is alerting, which is retriggering, which is webhooks and so on, seems like a small step, but it requires a lot of work. And this is what was more challenging in our case, to trying to automate and to get alert and the auto remediation on some scenarios. This is the most challenging.
Okay, you mentioned at some point that you something that basically differentiate this product from others is that you test the container images. So I was curious about how that happens. For example, I mean, I'm figuring stuff out and try to imagine things like, I don't know, for example, on the Java container you were talking about, what you do is to deploy some sort of applications on it made by you that are specifically designed to assess the vulnerabilities maybe, or to understand what's going on. So how all of that works.
Yeah, what we did is to, create some basics, because we cannot design complex applications to test all our images, but enough complexity to test that the resulting base image will continue working after any change. Meaning that for example, on Java, what we create is a Spring Boot example with different Spring Boot versions, with connectivity with a local database with SQLite 3. So if that application runs and seems healthy, means with a certain degree of confidence that the base image is well done. If the image, because if you rebuild the base image and the rebuilding is okay, it could means, or maybe it could not work your application on top of it, because if you, for example, if you install the latest version of SQLite driver because it had a vulnerability, and you try to patch it or whatever with an unstable driver, and you run your application and it doesn't work, yeah, your resulting image is okay. You can use it, but your application is not going to work. This is the main reason why we designed some applications, some basic application on PHP, on Java, on Node, on Python, to test a small functionality or the small integration between the base image and your application. More or less all follow the same pattern, which is an API or a CLI that runs and exposes a port and interacts with a database. For sure, there are other integrations that we cannot test, or we cannot easily test, like, I don't know, maybe with integration with DB2 from Oracle or with other legacy system. It's really difficult to test this kind of integration, but at least we are testing like the most common scenarios, so we can ensure that the resulting base image is healthy and working, let's say.
And you also mentioned now, while you were talking about this, you mentioned PHP, Node, Python, Java. That means that you are already providing at least the most common platforms and runtimes for people to build upon.
Yeah, exactly. Our catalog, the CCIs, the Certified Container Images from CHub. What we are offering is like the most standard or most common images, like Java, also for building with Maven and Gradle, Node, PHP, Python, Erlang, also .NET. We are also providing .NET. So yeah, we are covering almost the most regular scenarios. And we are open to implement more. We are continuously listening to our clients to add more and more certified images or secure images. Yeah.
Angel, thank you very much. We have no question from the chat right now, but I still encourage everybody to leave their own questions. You can also leave them in Italian, and we will cover them if there is time during the roundtable. Angel, thank you very, very much again. It was a pleasure to have you.
Me too. Thank you very much. Ciao, Rocco.
Bye, ciao.